Hi, good evening, everyone. Uh, Sorry for the confusion that we had regarding the timings today. I'm going to go ahead and I'm going to do these marathons very frequently now. Um, I will inform you in advance whenever we go ahead and whenever we do these marathons. The aim of the marathon would be to pick up any one subject and to go ahead and revise that subject thoroughly with you guys. Right? So the subject can be anything. It can be micro, macro, maths, stats, econometrics, anything. We will pick up on a subject. We will pick up on some questions related to subject and we'll try to revise that subject using those questions, right? But in the background, you go ahead and you continue revising your syllabus also and keep checking how many questions you are able to do in the marathon, right? The faster you reply in the marathon, which means that you are able to now understand the topic well. That's the idea behind these marathons. So go ahead, take this first question, beta. Try to do this question. Try not to take more than 5 minutes to solve any question. Okay. So this is the question. It says, an analyst is trying to estimate the demand for rice, and there is a model that is given to you, and the R square value is also given to you. It says the standard error associated with coefficient y is 0.1, that associated with p is 0.05, and n is 3. You're given another model, right? And you're given its slope coefficient standard errors. And it is asking which of the following is correct. Which of the following option is correct? Try to do this question. I am posting some excellent questions in the question bank. So make sure that you also do the question bank. Okay. Don't miss on the question bank. Anyone? So the question is based out of dummy variable. And in this question, we need to see. So you're also given the R square value. That is an important thing here. We need to see which model is better. Okay, B. Others, what do you think? One very important point in econometrics is that two models are comparable only if their y coefficient or y variable rather is in same format. I can compare two variables only if my y variable, it is in the same format. What do I mean by the same format? I mean that, I should be able to write so if I'm writing my y side as this, yi is equal to beta 1 plus beta 2 x2y, then other model cannot be ln yi equal to beta 1 plus beta 2 x2y plus ui. I cannot compare the R square of these models and tell which model is better. If this would have been yi, अगर दोनों ही yi होते, then the model which has higher R square is a better model. It's a better model. But in case you have yi in the different format, one is telling you yi and other is giving you ln yi. When yi is in the different format, then you cannot go ahead and then you cannot compare the two models, right? So if the dependent variable itself is different, then the two models cannot be compared. You cannot compare their goodness of fit. That is not something which is possible. So in this case, if you notice, in model 1, we notice that it is D here. And in model 2, we notice that this is D by N here. So my dependent variable is not in the same format, right? It is different. So since my dependent variable is different, I cannot compare the two models, right? So the correct answer to this question will be C, that the two models are not comparable in terms of fit. एक बारी दोबारा देख लो. Here I am saying that I would have had a column D. And I would have regressed this D on Y, on N, and on one more variable that is given, which is P. Whereas in the second case, I would have created a variable D divided by N. I would have got some values. And I have regressed this on Y and P. So the two models that I have in hand, these are different models. So if these models are different, how can I compare their goodness of fit? That cannot be compared. So the correct answer to this question will be C, that the models are not comparable in terms of their fit. I hope this is absolutely clear to you. Okay, try to go ahead and answer this question. Try to answer this question. You're given a model and it says that there is no intercept term and you're given the variance. So it is a model through origin. This is regression model through origin. You need to be very careful with the regression model through origin and what it means. ठीक है? इसका properties 150% it can be asked in exam. You have to remember its properties very, very well. The R square from this regression can be large. Least square residuals need not sum to 0. Mean square error is this. Least coefficient is this. Tell which of the following is not true. Okay. Which of the following statement is not true? B. Others? How about others? What do you think? Okay, B. Let's see. What are the properties of OLS estimators passing through origin? First, it's a सबसे पहला, the first thing that I had told you, that is that whenever you write the formula of beta, this is in non-deviation format. It is in the non-deviation format. It means that this beta is given to you by summation xy upon summation x square, beta 2 hat. And when you have a regular model, yi equal to beta 1 hat plus beta 2 hat xi, in that case, beta 2 hat was in the deviation format. It will be in the deviation format. And when you go ahead and when you open this up, you will get this. Remember, we opened it in one of the lectures. You will get exactly this. You can try opening this up. This was the other formula that you had. You can just see this into this summation xi yi minus y bar summation xi minus x bar summation yi minus summation x bar y bar upon, you can just open the denominator also. Just do some changes here. जैसे mean की जगह पे summation y by n लिखो, take n common, you will get exactly this. So this is the formula in the deviation format. But in case of passing through the origin, it is in the absolute format. It is in the absolute terms. So when it passes through the origin, it is in the absolute terms. इसी से don't we know that at least the last option is incorrect because it is not in the absolute terms, isn't it? So we know that option D definitely is incorrect. It is not true because it has to be in the absolute terms. अब बाकी actually true है. R square from regression can be large. So we said that this R square, it has no meaning. It has no meaning when it passes through origin. It can be negative, it can be positive, it can be zero, it can be very large, very small. So this is correct. Least square residuals need not sum to zero. This is correct. The summation of the error term need not be zero. Summation of error term was zero only when we had the intercept model. In this case, it may or may not be equal to zero. It may or may not be equal to zero. So this is correct. The mean square error is given by this summation yi minus y hat. Summation yi minus y hat upon n minus 1. No. अगर mean square error है, तो deviation will be from mean ना, not from y hat. Deviation should be from mean. So that is also incorrect, right? Sorry, mean square error. So this is the MSE. So this is the mean square of RSS, residual sum of square. This is saying mean square error, mean square of the error term. So residual sum of square. And what is the mean square of the residual sum of square? We have done this. It is nothing but summation ui square upon n minus k. In this case, what is my number of parameters? I just have one parameter, that is basically this beta 2. My model is this, yi equal to beta 2 hat xi plus ui. So I just have one k parameter. So what will happen here? I will get this is equal to summation ui square upon n minus 1. Right? You can put hat, this is sample. And what is ui hat? The difference between actual and predicted values. isn't it? So I can rewrite this thing as summation yi minus y hat whole square by n minus 1. That means this is correct. This is the correct statement. This is mean square of the error terms, MSE, mean square of error terms, right? So this is correct. This formula is also correct. So the only thing which is incorrect is option number D. You don't only have to look at what is incorrect. The idea of these questions is to give you information about what is correct also. जो ठीक है उसको भी सीखना जरूरी है, उसको भी समझना जरूरी है, उसके नोट्स बनाना भी जरूरी है. It is important that you make a note of this, you make a note of this, you make a note of this, because this can also come in exam this year, है ना? तो हमें हर चीज को clearly we have to write in notes. Isn't the error term free of degrees of freedom? No, no, no. Remember, we had done an F test. In F test, we had written ESS, RSS, TSS. Then we had gone ahead and done mean sum of square. So we had done mean sum of square of explained, which was ESS divided by its degree of freedom. Then we had done mean sum of error terms, which was RSS divided by its degree of freedom. And then when we divided this and this, we got F calculated value. It is asking this. So it will be RSS divided by its degrees of freedom. Right? So no, we will have degrees of freedom there. Right? Okay. Any doubt in this? Anything else? Okay. The last part, let me explain. So it is asking find mean square error, right? So mean square error, what was the formula of mean square error? It was summation ui hat whole square divided by n minus k, where k is number of parameters. My model is yi equal to beta hat xi plus ui hat. So there are two ways to represent ui hat. ui hat can be the difference between actual and predicted values. Error क्या है? Actual और predicted value के बीच का gap था. Or from this equation also you can find ui hat, and ui hat can be yi minus beta hat xi. Sometimes they can use this also in exam. Currently they are using this form, right? Number of parameter k. How many k betas are there? Only one beta is there. So k is 1. So I can write this formula again, and I can say summation yi minus y hat whole square upon n minus 1. Upon n minus 1. This will be mean square error term. This is what they're asking. So this statement is true. You can call it like that. Absolutely. MSc is variance of sample error. Definitely. Mean square error is that. Yes. Is this clear? Okay. Anything else in this question which is not clear? Anything? Make a note of the formulas very, very well. Formulas will be asked in exam from regression point of view. Okay. Any doubt in particular? Anything which is not clear in these options? I'll move on then. Try to do question number 11 now. Try this one. Give it a try.